All right, this lesson is going to focus on calculating percent water in hydrates. So we already have talked about hydrates a little bit. This is when you have an ionic compound in which one or more water molecules are attracted to the different ions. So it's a specific ratio of water to the rest of the salt. What we haven't talked about is that once it's heated, it becomes anhydrous and water is evaporated out. So we can use lab data to calculate the percentage of water. So you're going to keep seeing this pop up for each of the calculations, that when a hydrate is heated, the hydrate is going to undergo heating and then hydrous salt remains in the dish and the water evaporates out. So the change in mass between the hydrate to the anhydrous salt is going to provide you the grams of water. And we're still going to use the same formula as the previous lesson in order to do the percent by mass of water by using the water as your part divided by the hydrate as your whole, and then making sure you always show the times 100. So this was the calculation that we've done previously where we used the formula. Just remember the dot is not a multiplication symbol, it just means that you have two water molecules attached. And in the previous lesson we talked about how you would calculate the GFM of a hydrate, and that's going to be the whole hydrate's mass, and then we have two waters, so that would go up in your numerator in order to get the 14.7%. We can also use lab data in order to figure out the percentage of water. So this is an example of a question you could see. You have a 3-gram sample of a hydrated salt. It's heated to a constant mass of 2.32 grams. What's the percent by water in this hydrated salt? So if we think back to that formula, the 3-gram sample of the hydrated salt, that's your hydrate. When it's heated to a constant mass of 2.32, that's what remains in the dish or the container. So that's the mass of your anhydrous salt. Heating to a constant mass is just a way to indicate that all the water is evaporated out of the anhydrous salt, so only water remains. So when we find the difference between these two, we'll get the amount of water that evaporated out, so in this case 0.68 grams. Once we have the water amount and the hydrate amount, you just simply plug it into the formula that we've been using. So go ahead and plug those in, and then once you do the division and multiply by 100, you'll see that that hydrated salt has a percent by mass of 22.7%. If you look at the next question, it's very similar, so you can always pause the video and try it out yourself first. If we have a 5-gram sample, it's heated to a constant mass of 1.85 grams. What is the percent water by mass of this hydrated salt? So very similar, you start with that 5 grams of the hydrate that contains everything in it. We heat it to a constant mass, so that's going to be the anhydrous salt that's left in the dish. When we find the difference between those, that gives us the grams of water, which is that 3.15 grams. We plug it into the same formula, so we have our water divided by our hydrate times 100 to get 63%. You could be given different variables, just slightly. So if we have a 4-gram sample of a hydrate of nickel to bromide and it loses 0.793 grams of water when it's heated, what's the percent by mass? So in this case, they gave us the hydrate and they provide us the water, so we don't even have to worry about figuring out the anhydrous salt in this case. We can just go ahead and plug it into the formula, and we get 19.6%. All right, we will continue with this and practice it in class tomorrow.